In this tutorial, we are going to go over how to properly build a workflow with multiple ML models. Most workflows will only have one ML model at a time, but sometimes it is useful, especially during testing, to run multiple models to be able to compare and contrast their performance. Here in this workflow, the beginning steps we have are to simply load in the data and then to do some simple data cleaning. Additionally, we will index our string columns here to make them usable for each of our models. Next, we split the dataset into both testing and training. Up till now, this has been how we would normally build an ML model in a workflow. However, here we have a few important differentiating steps. The first is these two print nodes. These are nodes 10 and 9. These are important so that we can pass the same exact dataset to multiple models at the same time. If we were to not have these print rows and to instead connect all 6 of the following nodes into the split node, it would become impossible, as the split node only has 2 outputs, one that passes through the majority of the data, our training set, and one that passes through our testing set. So we need to use these print rows as a go-between between our nodes. This is a useful trick that can be used in multiple places to increase the number of connections allowed between nodes. Next, we have our 3 models. Here we have a generalized linear model, a gradient boosting machine, and XGBoost. As you will notice, these are all from the H2O library. You can also do this similar thing with the Spark library, but it is highly recommended to have all of your models come from the same library. Next, we have our H2O score. Different from a normal ML or single ML model workflow, we instead have to use 3 of these scoring nodes. Or if you were to use Spark models, you would need 3 of the prediction nodes and 3 regression evaluators. In this case, we also need to make sure to use the correct scoring or prediction node. In this case, as mentioned before, we are using everything from the H2O library. This will ensure consistency across our workflow and simplify the number of connections we need to make between our nodes. Now in the execution, we can see the model performance of each of our models. First, our gradient boosting machine, our generalized linear models, and finally, our XGBoost. For now, we will be focusing on the R-squared here. As you can see, the gradient boosting machine performed quite well at 0.981. Next, we have our generalized linear model. Here we can see that we have an R-squared of only 0.503. And finally, we have our XGBoost, which, as you can see, has an odd R-squared of negative 2.887. As you can see, building an ML model or multiple ML models in the same workflow is especially useful during testing, as we can directly compare each of the models. From this, we can take away which kind of model, in this case the gradient boosting machine, may be right for us, which ones perform mediocre, and which ones perform not well at all or have some issues. In the future now, we can build a dedicated XGBoost model if we are inclined to use that type of model and correct the errors that cause this especially weird and low R-squared. Thank you for listening.